Hi, I'm Benny D, and in this video we're going to be looking at determining transformations. So we've seen a lot of transformations and what happens to functions under different transformations, but we won't be able to have a function and go, okay, well, what has actually happened to it, okay, to get from one thing to the other. Okay, so we're having a look at this one now. Okay, so we're looking at finding a sequence of transformation which takes the graph of y equals x squared to y equals 2 outside of x take 2 squared plus 3. Now the book, I'm looking at the Cambridge book, it takes a pretty hardcore approach to this, okay, but they do mention that it can be pretty easy through inspection. I think that's the easier way to go. Okay, so when we look at this, we go, well, what's actually happened to it? Okay, well, we can see there's been a dilation, okay, happening here, okay, of a factor of 2 because it's outside our brackets, okay, in the y direction. Okay, now why do I know it's the y direction? Because once I've put my x value in here and the function itself, which is really that x squared part, has done its thing, it's then multiplied by 2. And let's go stretch up, so I know it's in the y direction. Okay, remember if it was in here, the 2 was in there, we would be saying by a factor of a half. Okay. And we've also had a translation of 2 units to the right. Okay, remember, don't get suckered in. Okay, it says -2. Okay, that means it moves it to the right. If it was +2, it would move it to the left. Okay, and a translation of 3 units up, or 3 units in the vertical direction, okay, or this could be 2 units in the positive x direction, 3 units up, 3 units to the positive y direction. A few ways of talking about this. Okay, we've got another work example here that we're going to have a look at as well. Okay, so we want to find the sequence of transformations which takes the graph of y equals 1 on x squared to 3 on 2x take 1 squared take 4. Okay, now I should mention too, a good order to stick with this is what we say DRT, okay, which is dilations, reflections, and translations. Okay, so when we have a look at this, what I'm going to do, okay, is I'm actually going to factorize what I've got here. Okay, so I'm going to say that really I've got y equals 3 on 2 outside of x take a half squared take 4. Okay, I like doing it like that because we need to do this anytime we're going to work with this and like factorize it or something like that, solve it, find x-intercepts. So I like it as a way to do it to actually then talk about it. Okay, the difference here is I'm going to actually, as soon as we do this, we've got to change our process. So saying DRT, that works really well for our previous example where we haven't factorized it. Where we've factorized it, we really need to think about working our inside out. Okay, so we're going to say we've had a translation, okay, of half a unit to the right. Okay, so we're taking care of that. We've also had a dilation of a factor of 1 or 2, okay, from the y-axis. Okay, now we've also had a dilation of a factor of 3, that's coming from our numerator up here, 3 from the x-axis. Okay, and we've also had this translation of 4 units down, or in the negative y direction. Okay, so I mentioned this DRT thing, this dilation, reflection, then translation, which works well for ones like this first one that we looked at, okay, because we didn't really have anything going on in our brackets, Okay, but when we had this example, as I said, I like to factorise them first. Okay, what's in our brackets, so we can talk about, like we talk about when we're going to graph it or solve it, things like that. Okay, so I like to go this way first, okay, just because I think it's nicer. But there's lots of different ways to do these. Often you have numerous ways of actually describing a transformation or a combination of transformations that all lead to the same thing. So just be mindful, as long as you're doing things correctly mathematically, you may actually have something that looks a little bit different to the process that they showed in the book, that sort of thing. Okay? And that's okay. There's just lots of ways to skin a cat.